Hey guys, Mr. Regan. Today we're going to look at surface area of prisms. So the surface area is the sum of the areas of each face of a prism. So we'll start out here with a rectangular prism. Think of like a tissue box, something like that. Rectangular prism has 6 faces. Okay, all prisms are made up of rectangular or parallelogram faces. And then the name of the prism comes from the shape of the base. So it turns out that a rectangular prism, all the faces are rectangles, so it's a rectangular prism. But you could think of it this way. There's the base, there's the base. Doesn't really matter which two you pick, as long as you pick two that are opposite each other. So they're rectangular faces, each base. All the other faces are rectangles also. Now you also notice that in a rectangular prism there's 6 faces. Over here we have a net. It's like, imagine I took a tissue box or a cereal box even, and I cut it open and unfolded it. You know, it would look like this, like a net. And here you can even see more clearly that there's 1, 2, 3, 4, 5, 6 different faces. Okay? If you think of a cereal box, when you're looking at the front of it, well, the front and the back have to be the same size. So like, imagine if this is the front and this is the back, they need to be the same size. If you're looking at the top and the bottom, maybe that's the top and that's the bottom, they have to be the same size, and then the two sides have to be the same size. So you have 6 faces, but really you have 3 faces that just repeat. Alright, so the formula that we're going to use to find the area of each of those faces is 2 times the length times the width, plus 2 times the length times the height, plus 2 times the width times the height. So you could think of this as your length, this as your width, and this as your height. Okay, I'm going to use cursive just because you see that a lot of times. The formula is written with cursive letters. Alright, so let's plug it in and try. Surface area equals 2 times the length, 6, times the width, 4, plus 2 times the length, 6, times the height, 5, plus 2 times the width, 4, I'm just plugging numbers in, times the height, 5. So if you think about it, you're multiplying 6 times 4, you're multiplying 5 times 4, and then you're multiplying 5 times 6, and you're doubling all of those. Alright, so 2 times 6 times 4 is 48. 2 times 6 times 5 is 60. And 2 times 4 times 5 is 40. Add those up, I get 148. And it's centimeters. And since we're talking about area, it's always to the second power. Remember, anything with area, we're talking about 2 dimensions, so it's always going to be to the second power. 148 centimeters to the second power, that's our surface area. All right, now we have a triangular prism. Okay, remember, I said triangles are made up of rectangular or parallelogram faces, and the bases are where the name of the prism comes from. So for here, this triangle and this triangle at each end, parallel to each other, they're the bases. That's why it's a triangular prism. And then everything else is rectangles. If you look over here at the net, you'll see you have those 2 triangles, and then you have your 3 rectangles. Okay, and these rectangles do not all have to be the same size. Alright, so just like in the rectangular prism, we're finding the area of each of those faces, and we're adding it up. But just like the rectangular prism, we had a little special formula to help. Triangular prism, we have a special formula to help also. Now, this one's a little trickier. Surface area equals PW plus 2B, where P is the perimeter of the triangular base. So the perimeter would be the distance around the triangle. W is the width of the prism, the distance from one base to the other, so from here to here. And B, capital B, is the area of the triangular base, so the area of that triangle. All right, so that's what we're looking at here. So let's see if we can use this. Surface area equals, all right, P, capital P, perimeter. So the distance is 3, 4, and 5. So perimeter just means the distance around. Add up those sides. 3 plus 4 plus 5 is 12 times W. Remember, this is our W, the width, distance from one triangle to the other. So 12 times 11 plus 2 times the area of the base. All right, our base is a triangle. Area of a triangle is 1/2 the base of the triangle times the height, lowercase b, base of the triangle. So here, the base of the triangle is this, the height of the triangle is this. Remember, height's always straight up and down, just like if I was measuring your height, you wouldn't lean, you would stand straight up and down. So, 1/2, the base is 4, the height is 3, and 1/2 times 4 times 3 is 6. All right, so capital B is 6. All right, let's multiply. 12 times 11, 132. Plus 2 times 6 is 12. Add those together, 145. And this was centimeters. And we said surface area is always units squared. So 145 centimeters squared. Okay, now if I went and I individually found the area of the two triangles and of each of those three rectangles and added them all up, I get that same answer. So this is just a formula to kind of help with all that. All right, we're going to look at another triangular prism. This is another triangular prism. This one's not a right triangular prism like the last one. This last one had a right triangle right there. This one does not. Okay, so it's going to be the same process. It's going to look a little different. So surface area equals the perimeter. That's the distance around the triangle. So that's our perimeter. 5, 5, and 5. They're all the same. So add up 5, 5, and 5. I get a perimeter of 15. Width, remember that's this distance here, is 10 plus 2 times the area of the base. Okay, I'm going to come down here and do the area, because remember, area of a triangle, 1/2 the base of the triangle, lowercase b, times the height of the triangle. So here, the base of the triangle is right here, 5. The height goes straight up and down, so it's not this, and it's not this. It's this right here, and it says that's 4. 1/2 times 5 times 4 is 10. So the area of the base, capital B, is 10. 15 times 10 is 150. 2 times 10, 20. 150 plus 20 is 170. This was meters, and units are always squared when we're dealing with area, surface area. 170 meters squared. So same idea, perimeter times the width of the prism plus 2 times the area of the base of the prism. All right, last one. Now we're going to look at a polygonal prism. Now this polygon happens to be 5 sides, so it's a pentagon. So we call that a pentagonal prism. Spell the word pentagon, add an AL. If it was an octagon, octagonal. Hexagon, hexagonal. All right, so we're going to use the same formula over here. Surface area equals, all right, the perimeter, the distance around this pentagon. Looks like it's a regular pentagon, meaning all the sides are the same, they're all 3. So 3 plus 3 plus 3 plus 3 plus 3, I get 15. The width, the distance from one base to the other, is 10. Plus 2 times the area of the base. Now, we don't really use a formula for area of a pentagon or a hexagon or an octagon, so you would be given this, and it says right here, capital B, area of the base, equals 15 inches squared. So I'm just going to use that number 15. Okay, so for any kind of prism other than a rectangular or triangular prism, we'll give you the area of the base, capital B. All right, 15 times 10 is 150. 2 times 15 is 30. 150 plus 30 is 180. This was inches, and we know that it's squared. All right, that's surface area of prisms. If it's a rectangular prism, 2 times the length times the width, plus 2 times the length times the height, plus 2 times the width times the height. Or think of it as the area of each of those 6 faces. Triangular prism, it would be surface area is the perimeter times the width of the prism plus 2 times the area of the base, or think of it as the area of the 3 rectangles, and then plus the area of the 2 triangles. This is just a formula to help you with that. And then if you have anything that's, other than a rectangular triangle, some kind of polygonal prism, sides of 5 or higher, we're going to use the same formula, and we're going to be given the area of the base. All right, good luck, guys.